Hello everyone, my name is Michael Coutrier and this is my first video tutorial on algorithms. So in getting started, let's look at the definition of what an algorithm is. So an algorithm is a logical sequence of discrete steps that describes a complete solution to a given problem, computable in a finite amount of time. So in reading this definition, we can point out one thing in the definition, that an algorithm is a logical sequence of discrete steps. And when we think about this, we can also think about programs and programming. So in programming as well, there's a logical sequence of steps in terms of how the program is supposed to be implemented. So this is why an algorithm is useful in programming. It helps to simplify and organize the coding process into a sequential order or a certain amount of steps. In C++ in particular, you have a set of instructions that you will use to build a solution to a problem. That's what you have. You can't invent things to it. You have a certain amount of elemental tools that you must use and build to create your solution to the problem. So you have to take your problem and break it down into subsets and deal with them individually and sequentially in C++. This might seem like a simple thing to do, but it requires many steps. In C++, you can't just say, go get the input from the user. That's not going to work or compile. You have to use a requisite statement in C++ language to prompt the user to input, and you have to use a requisite statement that inputs the information, etc., etc. So in saying all of this, let's look at a real-world example of an algorithm and we'll go from there. So example 1. So it says, write an algorithm that describes how someone is to sort a standard deck of cards from top to bottom as follows. Two of clubs through the ace of clubs, two of diamonds through the ace of diamonds, two of hearts through the ace of hearts, two of spades through the ace of spades. So think for a minute and think how you would create this algorithm in doing this process. One hint in doing so, you want to try to be as specific as possible, especially in an algorithm. So try to think as if you were trying to describe this particular algorithm or steps to a child. You know, a child doesn't know, so you would need to go through the necessary steps in telling them this, do that, and the next. So the solution or the algorithm for this would be, you would choose the top card of the stack and then turn it over. And through each card you turn over, you make 4 new stacks of 13 cards. And the 4 stacks, the 4 original stacks would be the stacks for the suits. So you would have club, diamond, heart, and spade. So with each of these 4 stacks, the order of the cards 2 through 10, jack, queen, king, and ace as well, would be suited through the 4 stacks. And in the end, you would combine the 4 stacks in the order club, diamond, heart, and spade. So this is a step-by-step process in doing this. So applying algorithms to our coding problems. So usually when we code or we create algorithms for our code, there are 2 ways to create this algorithm. And one is by doing a control flow chart, doing control flow charts. And that's, some programmers prefer to develop drawings showing how information passes from one state to another. And that is by creating diagrams, circles, ovals, and whatnot. And like I said, passing information, knowingly passing information from state to state. Next is pseudocode. You may develop your own pseudocode language containing all the usual coding structures of high-level languages and use it to write algorithms to solve your problem. When it says you may develop your own pseudocode language through usual coding constructs of higher level languages, what they mean is, you have the usual input data, output data, loops and whatnot, and you use your pseudocode and build around that. So if you want to input something, if you want to output something, if you want to loop this particular thing, you would say that in your pseudocode to create your own language. So these are pretty much the two ways in setting up an algorithm through flowchart. Now let's look at the pseudocode that goes with this this program. So this program is a grade calculator. So when you input a certain person's grade, you get their letter grade. So with this pseudocode, I'll go through the step-by-step process. So first, you prompt the student to enter his or her grade. Secondly, you input the grade. Third, if grade is greater than or equal to 90, print A. Else if grade is greater than or equal to 80, print B. Else if grade is greater than or equal to 70, print C. Else if grade is greater than or equal to 60, print D. Else print F. Now in looking at this pseudocode, we'll look at the next slide, and it'll show the code in which this pseudocode was made by. So we define our int and character, int being our percentage grade and character being our letter grade. And like the pseudocode said, I prompt the user to enter a grade. So enter your number grade, you input it, and if the number is outside of the boundaries of 0 and 100, the grade will equal n, and therefore the cout statement will say n stands for invalid. So else if the number is less than or equal to 80, grade is equal to A. Else if number is greater than or equal to 80, grade equals B. Else if number is greater than or equal to 70, grade C. So on and so forth. And then it gives you the letter grade on which you got when you put in the number grade. The letter grade is such and such. So let's go to the next slide. So in going to the next slide, I'm going to try to compare an algorithm to a formula or an equation. So a formula, in many ways, an algorithm is kind of like a formula, because like a formula, it indicates a type of procedure when used to therefore create a solution from that formula. So if we look at this quadratic equation right here at the bottom, right here, we have 2x squared plus 5x plus 3 equals 0. So our A is equal to 2, our B is equal to 5, our C is equal to 3. And once we get this, we input it into our formula, our quadratic formula right here, and thus we get our solution at the bottom. So again, in saying an algorithm in many ways is like a formula, because a formula indicates the type of procedure when used to therefore create a solution, kind of like an algorithm. So, in going to our next slide, that is the end. And I'm happy to say that I hope that people watching this have gained knowledge from what I've said about algorithms. So long and farewell.